Hey, very good morning, students. Let us look into the flip-flop conversions. So, how to convert a flip-flop from one to other is the topic. So, in this video, we are going to see how to convert SR flip-flop to T flip-flop. So, for that, we have 5 steps. What is the first step? Note the available and required flip-flop. So, what is available? SR is available flip-flop. What is required? I need to convert SR to T. So, my required flip-flop is T. I am done with step 1. What is the step 2? Write the characteristic table of required flip-flop. So, I need to write the characteristic table of required flip-flop. What is required flip-flop? T. So, I need to write the characteristic table of T. What is characteristic table? Writing Q of n plus 1 depending upon the present state and input. So, writing the next state, understanding or writing the next state depending upon the present state and T is a characteristic table. You all know T stands for toggle flip-flop. If T is 0, whatever you have in Q will come as such. Okay. When T is 1, the output toggles. If Q is 0, next state will be Q of n plus 1. Is it clear? Very simple. If T is 0, Qn will be equal to Q of n plus 1. If T is 1, it toggles. What is toggle? Inverse. Qn is 0, it becomes 1. Now T is 0, no change. 1, 1. T is 1, change. 1 becomes 0. This is how you write the characteristic table of T flip-flop. Now what is that you need to write? The next thing, write the excitation table of the available flip-flop. What is available? SR flip-flop. Write the excitation table of SR flip-flop. You know excitation table is written. Inputs should be present state. Based on the present state and next state, what are the values of S and R? So this characteristic tables and excitation table, already I have done a separate video. You can go there and look into it and understand what it is. Now we are just writing the characteristic table of required, excitation table of available flip-flop. For available flip-flop is SR, so I am writing the excitation of available flip-flop. Now with the characteristic table of required and excitation table of available flip-flop, we are going to identify the S and R values, okay, which is available. Okay, so how are you going to do that? This is done in a very simple way. First, you need to know what is Qn and Q of n plus 1. Qn is 0, Q of n plus 1 is 0. Qn is 0, Q of n plus 1 is 0. What is S and R value? 0, don't care. Right? 0, don't care. Done. Qn is 0, Q of n plus 1 is 1. Qn is 0, Q of n plus 1 is 1. What is S and R values? 1, 0. Fill 1 and 0. Qn is 1, Q of n plus 1 is 1. Qn is 1, Q of n plus 1 is 1. What is SR values? Don't care, 0. Don't care, 0. Qn is 1, Q of n plus 1 is 0. Qn is 1, Q of n plus 1 is 0. What is SR value? 0, don't care. 0, don't care. Have I done this? Done. Now what is the last step? Last step is I need to write the equation for S and equation for R depending upon the inputs. So how many inputs are we have? Qn and T. So it is a 2 variable K map. I need to draw a 2 variable K map between Qn and T. So how will I write it? 2 variable K map will have 4 cells. Okay. So what is S value? 0, 1, don't care, 0. 0, 1, don't care, 0. Fill it. Since I cannot pair it, I take an individual pair. So what is the answer I get? S is equal to, this is Qn 0. 0 means Qn bar. This is 1. 1 means T. S is equal to T Qn bar. Over. Now come to R. Now what is that I will do? What is the equation for R? Don't care, 0, 0, 1. Don't care, 0, 0, 1. What is this value? Qn T. So R is equal to Qn T. I am done with this. What is the next state? Next state is I need to write That's the logic diagram. So what is available? SR flip-flop. So this is my SR flip-flop. I have S, I have R. I have output Qn and Qn bar. Now what is that I need to do? S should be connected to what? T, Qn bar. So I take an input T that need to be multiplied with Qn bar. So I go to Qn bar, take a wire, use AND gate to do that function. So I get what output? T Qn bar here. That is connected to what? Yes. Clear? So the S input is connected to what? T Qn bar. So this is my T. This is my Qn bar. I'm connecting it with AND gate so that I get an output T Qn bar that is connected to yes. Done. Now go to the next one, R. R should be connected to T Qn. So T comes as such. Qn comes from here, which is given to an AND gate. So that output of this is TQn, which is given to the input of R, which is given to the input of R. So having converted SR flip-flop to T flip-flop, this is how you need to do. So SR flip-flop has two inputs S and R, outputs Qn and Qn bar, and a clock signal. Now T flip-flop, how we can get a T flip-flop? By connecting S terminal with TQn bar, TQn bar, connecting R terminal with TQn, R terminal with T and Qn. This is the final circuit diagram of the conversion. So it is a very simple 5-step process. Step 1, write the available flip-flop, required flip-flop. Step 2, write the characteristic of the required flip-flop, excitation of available flip-flop. Step 3, write the from the characteristic table and excitation table, derive S value and R value. Write the Boolean expression for S, Boolean expression for R. With the help of the Boolean expression, draw the circuit diagram. Keeping SR fixed, write the T flip-flop circuit diagram. Clear? Thank you.